Okay, let's look at some other problems from our last couple modules to help us prepare for our final exam. So this first problem says convert the rectangular point 3, 7 into polar coordinates. So essentially this point is an xy point. So this is an xy, and we want to turn it into a point that has r and theta. Well, we have formulas for that, pretty simple, where r is going to equal the square root of x squared plus y squared, and theta, the reference angle for theta, is going to equal the inverse tangent of y over x. So we're going to use these two formulas to find r and to find theta. So since we have the point 37, I want to find r. R is going to be the square root of x squared plus y squared. So it's the square root of 3 squared plus 7 squared. 3 squared is 9. 7 squared is 49. So this is the square root of 58. So the first part of our answer, we'll write it up here, we know it's going to be the square root of 58. That's the radius. That's how far from the pole, from the origin. So now we're going to try to find our angle, our reference angle. Now 3, 7, we know is in quadrant 1, over 3 up 7. So if it's in quadrant 1, the arctangent, the inverse tangent, is just going to give us whatever our answer is. We won't have to do any other work. If it's in quadrant 2 or quadrant 3 or something like that, we might have to do a little more work. So if I want to find the angle theta will be equal to the arctan, the inverse tan, of y over x. And in this case, that's 7 over 3. And again, that's just from the point 3, 7. So if I do the inverse tan of 7 over 3, I get 66.8. That would be in degrees. So this point would be 66.8 degrees. So the point 3, 7, if we kind of think about graphing it, so 3, 7 is and go out square root of 58 units, I'll end at the same point. So whether using the rectangle or the polar, you get to the same point. Okay, let's look at number 2. It says convert the polar point negative 5, 15 into rectangular coordinates. So this is saying we have r and theta. We know what r and theta is. We want to turn that to x and y. Well, just like we had these formulas up above where we had r was equal to this and theta was equal to this, we have even easier formulas when we're going from polar to rectangular. We know x equals r cosine theta. And we know y equals r sine theta. So since we know what r and theta are, we're just really going to plug this in. So r is negative 5 times the cosine of 15 degrees. And y is going to equal negative 5 times the sine of 15 degrees. So I'll just basically plug those in my calculator. So what I get is the 2 points, is I get an x of negative 1.29. I'll go to 2 decimals. Or pardon me, that's y. Our x is negative 4.83. And the y is going to be negative 1.29. So this point is in the same place as negative 515 in polar. Alright, this next one kind of is a graphing problem where we have a polar equation and we're trying to plot it. So we can pick some points to graph and then to plot, and then we can graph it over here on our polar graph. Of course, graphing this on Desmos or a TI graphing calculator will give us a really good idea of what it looks like. So what I'm going to do, I'm just going to pick some random angles. So I'll pick 0 degrees, just for fun. I'll pick 45. I'll pick 90. I'm just trying to pick nice angles, 180. Maybe I'll pick, I don't know, just arbitrarily, let's pick 210. So these are just regular angles that I'm picking. And so what I'll do is I'll plug those in for theta and I'll get some r's. So for example, for 0, I'll put in the calculator 3 plus 4 cosine of 0 degrees. And make sure your calculator is in degree mode, especially if you're using the Desmos, which does, you have to actually change it under the wrench. So 3 plus 4 cosine 0 is 7. So the y value for 7 degrees is 7. If I do the same thing, instead of putting 0, I put 45, I get 5.82. And we'll plot all these points, and then we'll use our calculator to kind of fill in our graph. If I do 90, so 3 plus 4 cosine 90, I get 3. If I do 180, then I'll get negative 1. If I get 210, and this will be a weird one, so I'll get negative 4.46, we'll say. So really small negative. So now that I have these points, I can plot them over here on my polar graph. So remember, we'll go to the angle first. So the first one says 0 degrees, which is along the positive x-axis. And we're going to go out 7 units. Now this only goes out to 5, so 7 will be way out here. Put a point there. The next one says go 45. Now this is the 45 degree spoke right here. And we want to go up 5.82. So that's 1, 2, 3, 4, 5. So a little past, it's almost to the 6th one, which isn't there, but it's okay. So then we have 390. So we go 90, which is vertical, and we go out 3. 1, 2, 3. So there's that. So you can start to see our graph is going to look something like this. And they have 180. So if I go to 180, that's over on the negative x-axis. But I go negative 1, so that means I go the other direction. So it looks something like this. And then 210. 210 is over here, but I'm going out negative 0.46. That means I go back over this direction. So this is fine, but it's kind of hard to see what's happening in the graph even with this. But what I can do is I can kind of fill in. And what I see from my graphing calculator is this is going to kind of come here. It's going to make a little loop like this. And then I kind of go back out like this. So I have kind of this general idea of what the graph looks like. I plotted a couple points, but I'm really dependent on my calculator or Desmos or something to really get the good idea what this is, because these graphs can look like pretty much anything. Okay, let's look at a couple examples where we go back and review some of our vector stuff. So here we have two vectors. We have vector A is 3i minus 4j. We could also write it in the bracket notation where A is equal to 3 comma negative 4. And B is equal to negative 2i plus 5j. Or we could also write this one in the bracket form where it would be negative 2, 5. Either way would be fine, just depending how you like to write it. Now, irregardless, when we're trying to find A plus B, we're just going to add the A parts and the B parts to get vector A plus B. So in this case, if I'm adding vector A plus B, I take 3 plus negative 2, which is just the x parts. 3 plus negative 2 is simply 1. And negative 4 plus 5, negative 4 is the y of the first, 5 is the y of the second, is simply 1 as well. So vector A plus B is going to point somewhere in the positive quadrant 1, kind of in this direction. So it says, what is the magnitude of A plus B? Let's draw this a little bigger. So we have 1 here, and this is our vector A plus B. So when we say the magnitude, we basically want to know how long is that vector. So you can make this triangle. If you make this kind of blue triangle here, you know one side of this triangle is 1 and the other side is 1. So your magnitude is essentially just the hypotenuse of a right triangle. So we could just do Pythagorean theorem, 1 squared plus 1 squared equals c squared. And c squared is going to be our magnitude. So 1 squared and 1 squared are 1, so 1 plus 1 is 2 equals c squared. So if I take the square root, the hypotenuse, c of this is square root of 2. And so that is our magnitude. So that magnitude is square root of 2. Now the next question basically asks, can we find the direction of this vector? Which way does it point? Well, again, we have a right triangle, so really we're just trying to find this angle right here, theta. Now you can do this lots of ways, but if you think of this as, say, opposite of the right triangle, and this adjacent, and this is of course hypotenuse, there's a lot of different ones you could do, but I'll just do tangent. So we know tangent of the angle equals opposite over adjacent, so that's 1 over 1 which is 1. So then to find the angle, I'll take the inverse tangent of 1, and that will give me my direction, which is 45. So really all we're trying to do here is we're trying to find an angle in a right triangle. We're trying to find the hypotenuse of a right triangle when you're trying to find the magnitude and you're trying to find the direction. Okay, D says, what is negative 4a minus 7b? So essentially what we're doing here is we're going to take 4 times a. Now if we remember what a is from above, a is going to be 3 and negative 4, and b is going to be negative 2 and 5. So essentially what we're trying to do is we're trying to do negative 4 times vector a, which is 3, negative 4. And then we're trying to subtract 7 from vector b, which is negative 2 and 5. Now you can do this lots of ways, but I'm going to multiply the first one by negative 4, because I'm going to multiply each component by negative 4. So that's going to be negative 4 times 3, which is negative 12. Negative 4 times negative 4, which is positive 16. And here I can multiply everything by 7. I'm going to multiply everything by negative 7 and then just add the vectors. So I'm basically distributing, kind of multiplying everything by this whole value. So that's going to give me positive 14, and that's going to give me negative 35. And then I'll simply add the components. So negative 12 plus 14 is going to give me 2. That's just adding the x parts. And then 16 plus a negative 35 is going to give me a negative 19. So this is the vector, negative 4a minus 7b. Okay, the final question says, what is the angle between the two vectors? So if we think about what these look like, we have 3, negative 4, that's A. This is vector A. And then vector B is negative 2, 5, so 1, 2, 1, 2, 3, 4, 5. This vector points something like here. So what we're trying to figure out is we're trying to find out how big an angle is between these two vectors. Now there was a pretty easy formula for that, kind of a long one, but not too bad. It is the cosine of theta equals the dot product between the two vectors, so A dot B, over the magnitude of A, so basically how long A is, times the magnitude of B, which is how long B is. Now if you remember from above, the magnitudes are just basically doing Pythagorean theorem and finding the hypotenuse, and the dot product is when we multiply the x's and add them to the multiply of the y. So if I do the dot product of a and b, I'm going to basically multiply the two x values, which are 3 times negative 2, and I'm going to add that to the two y values multiplied together, which is negative 4 times 5. So that's the dot product of the two vectors. Now as for the magnitudes, I'm just going to do the square root of each one of the parts added together. So in this case, this would be the square root of 3 squared plus negative 4 squared. So that's the magnitude of A. You could set up a triangle, but we know it's going to be Pythagorean theorem, so we're going to square each side, add them, and then take the square root. And this one is going to be the square root of negative 2 squared, and I'm putting the negatives in parentheses just so it squares correctly, plus 5 squares. You can do it for everything, but especially the negatives are very important. So the cosine of theta is going to equal to negative 6 minus 20. On the bottom, we have the square root of 3 squared plus 4 squared. That's going to be just 5. And this other one is not going to turn out quite as nice. It's 25 and 4, so it's the square root of 29. we're basically saying the cosine of theta is equal to negative 26 over 5 square root of 29. That's fine. But that's not the angle we want, that's just the ratio of the cosine. So to get the angle, we'll just take the inverse cosine of that, and that will give us our answer. So the inverse cosine of negative 26 over 5 square root of 29 will give us the angle between the two vectors. Now again, if you're putting this in the calculator, make sure you put another set of parentheses around the bottom, just so the calculator calculates it correctly. So when I do this, I get 164.9 degrees. So it's a pretty big angle, almost straight, but if you remember what our picture looked from above, I mean it's a pretty big angle, very close to 180, so it kind of makes sense. Okay, our last couple problems are about arithmetic and geometric sequences. So the first one says, what's the 99th term of the arithmetic sequence, negative 4, 1, 6, 11, so on and so forth. So arithmetic means we're basically adding the same number each time. So in this case, hopefully you can see that we're basically adding 5 each time. From 1 to 6, 6 to 11, negative 4 to 1, we're adding 5. So the general form of any arithmetic sequence, a sub n, is a sub 1 plus the common difference, and the common difference in this case is going to be 5, times n minus 1. So we can actually find a formula for the nth term of this sequence. So the first term is negative 4 plus the common difference, which is 5, times n minus 1. So if I distribute the 5, we know a sub n is going to equal negative 4 plus 5n minus 5, and then I can combine these two like terms, and so I know a sub n equals negative 9 plus 5n. Now we kind of did this formula because now I can find the 99th term, because there's no way I'm adding 5 all those times to figure out what that is. But now that I know what this formula, all I have to do is say a of 99 would be negative 9 plus 5n, well n is 99. So getting that formula is extremely important, because now all the work is really done for you. So 4 times 99 plus the negative 9 is going to give us 486. So if you were to keep adding 5 to that sequence and eventually get to the 99th term, it would be 486. Okay, number 6 says, what is the explicit form of the geometric sequence 16, 8, 4, 2? So geometric is when you're multiplying by a number, and if you remember, the explicit form of that is a sub n equals a sub 1 times r to the n minus 1. Now r is the common ratio, it's what you're multiplying by each time, and a1 is of course the first term. So if I know the first term is 16, so that would go there. I don't know what the common ratio is quite yet, but I know n minus 1 goes up here. So if I'm thinking about what's the common ratio, what do I multiply from 16 to 8, 8 to 4, 4 to 2? Well, really what I'm doing is I'm dividing by 2. But I have to figure out what multiplies that. So if you're dividing by 2, because we're obviously dividing by 2, we'll make the common ratio 1/2. Because dividing by 2 is the same as multiplying by 1/2. So our explicit formula of this geometric sequence would be a sub n equals 16 times 1/2 to the n minus 1. Now, of course, if I wanted to find the some term like I did above, the 99th term, I could just plug in 99 or 100 or whatever I want for n, and it would find me that term in this geometric sequence. So this last one says, given a1 equals 6 and an equals 3 a sub n minus 1 minus 2, list the first 5 terms of the sequence. So this is a recursive sequence. So obviously the first term is 6. So a1 equals 6. Now what this means is this says if a sub n, so whatever term I want to find. So let's put a 2 in for n. So a sub 2, if I put a 2 in, would be 3, and then 2 minus 1 would be a1 minus 2. So basically it says take 3 times the term before and subtract 2. So this is going to be 3 times 6 minus 2. Because I'm multiplying 3 times the term before, because remember, this means term before, and I'm subtracting 2. So that's 18 minus 2, that's 16. So far my sequence is 6 and then 16, and now I'll do it again. So A3 is going to be 3 times the previous term, which was 16, minus 2. 3 times 16 is 48. 48 minus 2 is 46. So 46 would be my third term. So again, now it just kind of becomes a pattern. So 3 times 46 minus 2. 3 times the previous term minus 2. So 3 times 46 is 138. Minus 2 is 136. So that's the fourth term. And then the fifth term would be 3 times the previous term. So 3 times 136 minus 2. So 3 times 136 is 408. 408 minus 2 would be 406. So you're basically just following the rule to just get each subsequent term based on the previous term. Not too bad. Kind of the rules above where they're explicit, you just plug in numbers, a little nicer, but these recursive ones certainly have their value too. Okay, so this was our final review for our final exam. Please let me know if you have any questions.